To begin our talk about geometry, we need to start with some definitions. First thing we talk about is a point. A point doesn't have a very formal definition, but we do usually use letters to represent it. As we start adding points to any kind of shape we're talking about, then we do get definite definitions we can talk about. So the first one we could say is a line. So a line is defined by 2 points. Notice that it continues in both directions pretty much forever. A plane is a 2-dimensional shape that needs 3 points, and it's important that they're not linear. So these 3 points wouldn't make one line. They have to be kind of away from each other. The arrows really make a difference when we're talking about lines, and so we want to talk about what if we have 1 arrow, 2 arrows, no arrows at all, what would happen? So a line has arrows that go in both directions, but if we were just to use from one point to the other point and that's it to make this finite shape, then we would call that a line segment. So it's a beginning and an end where a line goes on forever. Line segments are much more practical than lines because most things don't really go on forever. So if we were trying to pick the distance between 2 cities or measure it, then that would form a line. If we're looking at sides of a plane, and it doesn't matter if that would be a triangle, a square, a rectangle, but any of that side length, that would be a line segment. So segments are what we normally use in the real world, but lines is what we generally think about, I think, with geometry. All right, well, what if we only had 1 arrow? So they're very close definitions here, and they look kind of the same, so really pay attention to the difference in what's going on. A ray has a starting point, and then it goes in one direction. So notice that darkened end point for the ray. A half line does not include the starting point, so it is open. So they look very similar, but the only difference is a ray includes the point, a half line does not. When we're looking at notation, I want you to see the diagram versus the symbol, that we don't always put the points on the symbol just to make it easier to read. So the line, you can see AB. You could have also said BA. Order doesn't really matter there, but notice I have the double-headed arrow. But then when I list a ray, I need to indicate the direction it's going. So you can see in this first one where I have AB, it starts at A and it goes through B. Versus the second one where I have the ray BA, it is starting at B and the arrow goes towards A. So I definitely can see where am I starting, what direction. And then the line segment, because it begins and ends, I could say AB with just a line on top or BA with just a line on top, no arrows at all. If you put 2 rays together, that forms an angle. So the common point that these 2 rays share, we call that the vertex. And when we write the angle, the vertex is listed in the middle. So when we're looking at the diagram on the left, you can see the P is in the middle. So we would want to say angle QPR or RPQ, but definitely want to put that P in the middle to indicate that that's the vertex. We do have a few operations we can talk about with lines and rays. We can talk about intersection and union. So intersection looks kind of like an upside down U, and it stands for all the points in common between a line and ray, whichever 2 we are trying to put together, where the union, which looks like a U, is the set of points belonging to either of the lines or rays. So intersection says what's in common, union says put it all together. So let's look at an example of that. I have this figure. It has a bunch of points on it. And the first thing we're going to talk about is finding the intersection of the line AC with the line FG. Let me see if I can help us out a little by drawing on here. So we can see this line AC is this entire, oops, kind of ugly, but it'll work. This entire line here is the line AC. So it goes from A through C, but it keeps going on forever. And then the line FG is this line up here. Okay. So intersection says what do they have in common? So the only thing they have in common is this point C. So let's look again. This second one, I have the ray EC, so I'm starting at E and I'm going through C. So it definitely has a starting point and then a direction that it's flowing. And then this is union, and again a ray, starting at C and going through G. You have more than one way you can write this. Either way that I write it, I need to start with E because this does form a ray, but I could say EC because it starts at E and goes through C, or if I wanted to, I could say EG to say start at E and go in the direction of G. Either one of those would be correct. All right. Let's see if I can get rid of that. Then we can talk about the next one. Okay. The next one says AD intersect DC. Again, AD is a ray, so I'm starting at A and I'm going in the direction of D, so it's going this way. And then we're intersecting, starting at D, and then going in the direction of C. Okay. So what I can see is they both include A, they both include D, and then they include everything in the middle of that, but nothing beyond. So nothing past D, nothing past A, so this would just be a line from A to D. All right, and then one last one. I have array BF, so here's B, and it's going towards F. And then it says union BC, so here's B and going through C. Now this, I have two rays together, so can you see this forms an angle? And this common B would be the vertex. So my answer is the angle BFC, or we said you can say it either way, CBF, wouldn't matter. All right, so here's a similar figure, and I really want you to pause the slide, see if you can do this. So pause the video, see if you can try these four. After you do it, come back and see if you got them correct, but do take the time to try it on your own before you continue with me. All right, so now that you're back, let's look at what you got. So the first one was this line AB, so we can make that right there. And I said intersect the line CD, so here's the CD, and they're not touching. Right, so since they're not touching, they don't have anything in common, so I drew this kind of a zero with a line through it, which means there is no intersection. There's nothing they have in common. These are considered parallel. Parallel lines do not cross. So having nothing as an answer, perfectly okay. Let's erase all of that. Okay, let's try it again. EB, so here is E, and it's going through B, and then intersect EA. And let's actually, just so we can see it a little better, let me pick a different color for that one. Maybe we'll do purple, and it goes this way. So I can see EB, EA, the only thing they have in common is the point E that they both started at. So notice that when it was just a singular point, I just wrote E and I put it in a set just to say, hey, the only thing they have in common is this one little point. All right, let's take that ink off. All right, here we have, again, array CD. So here's array starting at C and going through D. And then I have intersect FC, so here's F, and here's C going in this direction. And I drew them apart from each other just so you can see the overlap, because we are looking for the overlap. So from F to C, or from C to F, I have this line segment that they have in common. All right, and last one on here. I have, again, array from F to E, so it's going this way. And then I had union F to D, so one more time I have an angle. So I can say angle EFD, or I can say angle DFE, but I just want to make sure to put this F in